So the next step for inequalities is what we call OR inequalities. The last two were called AND because they go together. The way I kind of think about this is if I asked you to live with your mom and your dad, you're living with both. They're going together. Now, if your parents are split up, I would say, are you going to your mom's or your dad's? You can't go to both because they're not together. You're going to this side or you're going to this side. So the key when you see the word OR is you're going to be less or you're going to be greater. Your graph is actually going to be going apart. If it's an AND, when the variable's in the middle, that's when the graph goes together. So I see the word OR here. I know my graphs are not going to go together in between. It's two separate inequalities that now I'm graphing on the same number line. So the first inequality it says is x is less than 5. So I would go to 5. It's an open circle because it's not equal. And if x is less, it goes to the left. And I'm going to draw an arrow because technically it's going to keep going. It could be 4, 3, 2, 1, any number to the left of 5. Or it says x is greater than or equal to 8. So at 8, I'm going to put a closed circle because it can equal. And if x is greater, well, greater numbers than 8 go to the right. So basically, x can be any number less than 5, 4, 3, 2, 1. Or it can be any number greater than or equal to 8. So 8, 9, 10, 11, 12. And I know some of you ask, well, when would we ever see this in the real world? Well, sometimes when you go to a restaurant, you can order off of a kid's menu if you're 12 or under. I know some of you lie, but let's just say we're following the rules. You can order off the kids menu if you're 12 or younger. But you know who can usually also order off the kids menu? Seniors. So in order to order off the kids menu, you can be 12 years old or younger, or you could be 55 years old or older. But technically, in between 12 and 55, you're not supposed to be ordering off the kids menu. So that's the concept with the word OR. So remember, AND goes together, and OR is going to go apart. So now they're going to get a little bit more complicated because now instead of just already being solved for you, not only do you have to graph your answer, but first you have to find your answer. Well, if you know how to solve regular inequalities, this is actually pretty easy. All it is now instead of solving 1 for this problem, I have to solve 2. Well, 2 and x are still best friends, so they're going to stay together. So to get rid of the plus 7, I have to minus 7. And what I do to one side, I have to do to the other. So I still have 2x is less than, and 3 minus 7 is negative 4. Remember, don't get tricked. The negative doesn't mean I flip the inequality sign. The only thing that matters is if I'm going to divide or multiply by a negative. And right here, the best friend is positive 2. So for my final step, I'm going to be dividing by positive 2. Which, yes, my answer is a negative because one negative always wins. But since my best friend's a positive, I just leave my sign exactly the same. So negative 4 divided by 2 is negative 2. So my final answer is x is less than negative 2. But wait, I'm not finished. Because now with compound inequalities, remember, instead of just solving 1, I have to solve 2. So now we have to solve this other inequality. To get rid of a plus 5, I have to minus 5. And what I do to one side, I do to the other. So I get 5x is greater than or equal to 5. My final step, I have to divide by 5 on both sides. So I get x is greater than or equal to a positive 1. So my final answer is x is less than negative 2. Or x is greater than or equal to a positive 1. Remember, and has to fit both, but or can be working in the first one, or it has to work in the second one. So when I go to graph this, I still need to start one further to the left, which is negative 3. Then I have negative 2, negative 1, 0, 1, and 2. I'm going to have circles on my negative 2 and my positive 1. The positive 1 is the one that's included in my answer because I see that line underneath, so it's going to fill in and be a closed circle because it can equal 1. If x is less than the negative 2, from the negative 2 I go to the left, but x can be greater than 1, so from the 1 I go to the right. So basically x can be any of those negative numbers to the left of negative 2, and it can be any of those positive numbers to the right of 1. So realistically, the only thing x can't equal is just right here in the middle. So one more problem, let's make sure we have that practice down and we're ready to work on our own. Remember, we keep our best friends, so we have to minus 10 on both sides. So we still have 2x is greater than 6. My final step is dividing by that 2, so I get x is greater than 3. But I also have that last inequality over here. And what do you notice about that best friend? Remember, if the best friend is negative, this inequality sign has to flip. So I really only have a one-step inequality right here. To get rid of a multiply negative 3, I have to divide by negative 3. But what I do to one side, I have to do to the other. So I end up with x is less than negative 6. So for my final answer, I have x is greater than a positive 3, or x is less than a negative 6. So I have to include everything from negative 6 to positive 3. But remember, I need to really go one further, so I need to go from negative 7 to positive 4, which that's 10 or more numbers. So I'm going to go ahead and use my dot, dot, dot in the middle. So on the left is my negative, so I'm going to have negative 7, negative 6, negative 5, and I'm going to skip those numbers in the middle. And remember, the only reason we're allowed to skip those in the middle is if we put that dot, dot, dot to show there are numbers there. So I have negative 4, negative 3, negative 2, 1, 0, 1, and I'm going to, negative 1, 0, 1, I'm going to go on to 2, 3, 4. And the arrows on either side show that it's going to keep going in the other directions as well. So I'm going to put a circle on negative 6 and a circle on positive 3, neither of which are going to be closed. So now let's figure out, remember this word right here should tell us what direction. And means they're going to go together. The variable's not in the middle. The word or means they should be going apart. Well, this one is saying x is greater than 3. So from the positive 3, greater goes to the right. Or it can be less than negative 6. So from negative 6, I go less, which is to the left. So if the variable's in the middle, it's an and we should shade in between. If I see the word or, it means now my graph should be going apart.